Algebra 1, this is 2.6, ratios and proportions. So let's go over what a ratio is first, guys. A ratio is just a comparison of two numbers. So comparison of two numbers by division. So there's a couple different ways that we will write that. You can write it the really traditional way of x over y, x divided by y. You could say it's x to y, or sometimes they'll even use two dots. I'm not exactly sure what's that called. I don't know. Two dots there. Maybe x to y. So is that a semicolon? But the semicolon had the little comma on the bottom. Exactly what that's called, I'm not sure. But those are all ratios. Those are comparing numbers by division. So 2 to 4. 2 to 4 is a ratio of two things to four things, right? Then we can move on to a proportion. A proportion is an equation that has two ratios. Stating two ratios are equal. So now we basically take a ratio of 2 to 4. So we can even use that example. The ratio of 2 to 4 is the same thing as 8 to 16. Why would those be equivalent ratios? They're equivalent because they reduce down to 1/2, right? They both have the same ratio. So to be proportional is two ratios that are set equal to each other. They're called proportional. This problem, I want you guys to tell me, are these equivalent ratios?
No.
Are these equivalent ratios, yes or no? Now there's a couple different ways that we can handle this. To be equivalent ratios, reduce both fractions, and if they're the same, then yes, they're equivalent. If they're not the same, then no, they're not. That's one way. So, can I simplify 2/3?
No.
2/3 is already simplified. What about 16/24? They're both divisible by 2. Okay, so we can use that. So that's the same as 8/12. But that's also, okay, now divisible by 4. If I divide that by 4, that's 4 over, or not 4, but 2 over 3. Are these equivalent? Yes. So therefore, these are equivalent ratios. Now, watch what happens if I try this. What happens if I said, what if I said they are equivalent ratios? So this is different. I'm showing you a different method here. That it's asking us first, are they? So what I did was I wrote them down with an equal sign between them to say, yes, these are equivalent ratios. So what I can do now to prove that they are equivalent is cross multiply them. So I can do 2 times 24, and that will equal 3 times 16. What's 2 times 24? 48. 3 times 16? 48. They are the same. If they are the same, then they are equivalent ratios. If they're not the same number, then they know they were not the same. What we have here is using the idea that I just showed you about you can cross multiply to prove they're equivalent. I can cross multiply here to solve for an unknown. We're saying is that we have a proportion here where two ratios are equal to each other, but there's a missing number. We don't know what it is. So I am going to use the fact that I can cross multiply these, our corners, so that I can say 5x is equal to 3 times 10, or 5x equals 30. And then all you have to do is solve for 5, or solve for x, which means divide by 5. X equals 6. And if you're unsure, put 6 back in for 10, reduce both fractions, and they should be equivalent.